Hello everybody, so today we're going to be looking at gas exchange. This is a topic in science and it quite literally involves the exchange of gases. But to be able to use an analogy, let's say, we're going to be using a window. So let's say we've got an open window. Okay, an open window, you open the window to let in new gases and also let out old gases and have them back through the window in exchange for new gases. And this is like, let's say you want fresh air. You're going to get new air and get rid of the old wasted air, if that makes sense. And that quite simply is the exchange of gases. But to put it into context, the waste product in our body is carbon dioxide. So that would go out from the body, let's say, okay, out of the body into the air, let's say, that would be carbon dioxide. But the one we need from the air into our bodies through the lungs is oxygen. You can also think of it as gas exchange is like swapping toys with your friends. Your friend may be a carbon dioxide, they may love carbon dioxide, let's say they're toys, and your friend may have oxygen toys. You want to swap them to get both of them. So oxygen, the good toy, let's say, goes from the air into your lungs, whereas carbon dioxide goes out from your lungs back into the air. The extreme opposite of oxygen. Let's now focus on the question how gas exchange actually occurs and happens. Imagine the window is made up of tiny holes. Okay, and let's say the air outside is made up of lots of toys. And these toys are the oxygen. Inside your body, your cells need oxygen to play with. And also they just need to get rid of the toys that they don't play with, they don't need, which is carbon dioxide. So hopefully you can see the sort of exchange between having oxygen, you want that oxygen, but releasing carbon dioxide as waste. Now to put it into context, these tiny holes are like the alveoli in our lungs. The alveoli is really important in terms of gas exchange because these tiny holes let carbon dioxide out of your body and oxygen in. These are really important, and they're super small, tiny holes, and they play a very significant part in gas exchange. So that's a key component you should remember, hopefully. The oxygen comes into your body through your nose or your mouth and travels down to the lungs. So your alveoli, the little holes, are waiting to have the oxygen let in and pass it down through your blood. At the same time, carbon dioxide, which your body does not need, moves from the blood into the alveoli, so therefore it can go out through your nose or your mouth. You can see how oxygen and carbon dioxide are the complete opposites. Let's look at another question. Why do we need gas exchange? Imagine you're playing a game and you need to breathe. Oxygen is like the fuel for your body. Without it, it wouldn't be able to do too much. You can think of it like a car. It needs an engine, fuel. That is like oxygen. Without it, a car wouldn't work. Same as your body. Your cells need oxygen to make energy, so your cells can work and your body works. And this energy can be used to run, to play, and to do so much more. Think of it as a good fuel to keep your body running and have it reach its energy requirements. We can think of carbon dioxide as a leftover stuff, so we can call it the residue after oxygen has been used. It's like after you've eaten your sweets, okay? Because you'll still have the wrapping, and that is carbon dioxide. Not literally, but I mean as in the wrapping you still need to throw away, you can't eat it. we can think of it like carbon dioxide. After the oxygen has been used up, the wrapping, so the oxygen being the sweet, the carbon dioxide being the wrapping, you'll need to throw the wrapping in the bin. Same as carbon dioxide, we just don't need it, it's a waste product. And your body has to get rid of this waste. Okay, for the next question, we've been asked, how does the body know when to swap these gases? To put it really simply, it's quite obvious, but your body just knows when it's short on oxygen, when there's too much carbon dioxide, it will know. And so therefore, it will know when to get rid of this carbon dioxide and know when it needs some more oxygen. For example, when you exercise, your muscles will need more energy, okay, therefore more oxygen. This oxygen will keep you moving. So your body works faster to get oxygen in your blood and carbon dioxide out. When you're sitting, you're resting, so you won't need as much oxygen, so it's a slower swap between having more oxygen and getting rid of the waste carbon dioxide. And this is because you still breathe, so you still want that oxygen. Okay, question number 5, how do gases move? The gases move through the air like people running from one side to the other. Okay? So we can think of it as oxygen moving towards the blood, okay? And then, so oxygen moving towards the blood, but then carbon dioxide moving out of the blood. So let's just quickly focus on oxygen quickly. In the air there's lots of oxygen, and this oxygen is waiting around the lungs. The oxygen moves through the tiny holes, which is the alveoli, as we covered before, into the blood. And then the red blood cells carry it to where it needs. So we'll rewrite that out to make it clear. So we've got oxygen, alveoli, blood, and then the red blood cells, which I'll just contract it for short. That's abbreviated for red blood cells. The carbon dioxide, which is in the blood, needs to get out of the blood. It just needs to leave the body immediately. It moves through the same tiny holes, the alveoli. Let's just write that down so we're clear with everything. But however, it moves through the alveoli in the opposite direction. So back up and not going down. It goes out of the blood and then into the alveoli again. But remember, the first time it was in the opposite direction. So it's gone out again and it's going to be breathed out. Hopefully that makes sense, because I know the alveoli at the beginning and the end may be difficult to understand, but what we need to understand is the alveoli, the first time it went, the carbon dioxide went in a different direction compared to the last. Okay, let's move on to the 6th question. How does this help the body? So how does gas exchange actually help the body? Your body is like a big team of players, okay? Let's say we're playing football. Okay, that's just a rough illustration. Your body is making sure every gas can play this game. Okay, pass the ball. Without enough oxygen and without getting rid of the carbon dioxide, you can't play the game, because obviously you're going to have to get rid of the carbon dioxide so one person can eventually win. So oxygen, it helps the muscles and organs work like a player helping score goals. So let's say the carbon dioxide is like the waste, you just don't need it. And we're not going to put it in football context because that may go the wrong way, but we can think of it as a sweet wrapping analogy where the wrappers we just don't need, we throw them in the bin anyways. Okay, so this is basically it, but to summarise, gas exchange is a process that involves diffusion, Alveoli are tiny air sacs in the lungs.